begin recording now. See if it goes on. Give it a moment. It's just sending onto the screen. Here we go. Now, what I'd like you to do is I would like you to go on to example number 2. So this is on your first, second, third, fourth page. So at the top of the title, at the top of the page, it should say example number 2 using the compound interest formula. This is what we've already covered a bit yesterday. What I'd like you to do first is, if you have a highlighter or if you have a pen, please put a star next to this section. If you only have a pen, or if you have a highlighter, highlight this entire question here, because it's easy to lose what the question is talking about because there's a lot of notes going on. This is also a chance for us to recap what happened yesterday. Now, yesterday we had a look at the compound interest formula, but then we looked at how to calculate this step by step as well. So basically, if I go back up to the same example that we did yesterday, we found how much the investment was worth after 1 year, after 1 year, after 2 years, and after 3 years. So this is a step by step. But then we also use the compound interest formula because we needed to find a shortcut way to get to this number here. We need a shortcut. So the shortcut is to use the compound interest formula. Okay. Notice how here there's a little r. Today we're actually going to look at this whole bracket here. We're going to look at the entire bracket there, and it's going to be called capital R. Okay. Now, if we go back down to example number 2 here, it's a very similar kind of similar kind of question to yesterday's one. So we'll use this to start off with and revise. Okay. What's the first thing that we do here as we read the question? Annotate. Fantastic. So what does annotate mean? What's one idea of annotating? Sorry? Sorry? Edit a sentence. Yeah, we can edit the sentence. Taking notes, that's one. Sorry? Highlight, correct. And if you don't have a highlighter, underline. Okay, so this is already highlighted. I'm going to underline. What's the first thing we want to underline here?
14K.
14K. Label that as P. For what does P stand for? Principal. Excellent. What's the scenario here? Are we putting in money or are we borrowing money? Putting in money. So what's the word for it? Invest. Okay, I might underline that as well, just for the sake of understanding that it's an investment. Okay. It says here, William invests the money at 9% per annum. R, little r or capital R? Little r. So, whoa. Jesus. Underline, label. Now, what does 5 years? T or Y? Okay, so I'm going to use T. I'm actually going to use Y just for the sake of it, just so that you can switch it up, yeah? But just understand if you use T or if you use Y, it's the same thing. So here, first warning, actually second warning, I'd like you to move. You boys are not to sit next to each other. Are you talking to the teacher? No, you're not. Move. Tia, you're gonna move.
What here?
Okay, Imran, you're gonna move
Where?
to the bench. Or you're gonna pull out another table and you're gonna move.
All done. Oh, that's it.
Okay, is this simple interest or compound interest? Compound. Where? Compounded annually. Okay, so we need to underline that idea. Thank you. And is there any other keywords? Annually. Okay, so we're going to underline the word annually here. What does the word annual mean? Once a year. So what letter are we talking about? C, correct? And what does C equal to? 1 in this case. Excellent. Okay, now you can see here, this is like, that looks very similar to our compound interest formula, yeah? Except something's been collapsed down. The R. So this capital R here was collapsed down. What usually goes there? We forgot the times. C. And then to the power of n, but you can already see the power of n is already down there, right? So you know how like you click on a folder, just as an example here, you know how you click on a folder and you go, okay, I want to see what's inside of it. You would click on, let's say, documents. And you would do a drop-down menu. See how it unhides all those folders and then you collapse it? So unhide, collapse, right? That's the same thing here with a capital R. It's just collapsing everything. So can you please write down that equation? Okay, exited. Out. Don't argue. Exited. Nat, can you write him a note? Thank you. That's the problem. You're not doing anything at all. So you're going to get exited, and I'll see you at the end of the day. Thank you. Distract the class, that's what. Okay. So you can see here, this R here is being collapsed. Okay, so if we want to write the expanded version, we would just incorporate that in and replace the capital R with a bracket. Understood? So we can write the expanded version like so, right? Except write that in there. Now, you can see they've gone through the formula already. So this is the working out. Part 1, part 2, part 3, you can actually see how much it's gone increased. If you look at this A here, what's that value there? What's this 21,540? Yes, so it's the total amount after 5 years. So if you take all of these ingredients here and you put it into the formula, which is A, P times, instead of the capital R, we're going to write 1 plus R over 100 times C to the power of n. Okay, you put all the numbers in and it will work out. So what I'd like you to do now is actually try a question. Let's actually go here now. So application. So at the top of the page, you should see the word applications of compound interest. Now, when you're doing these questions here, you might have to flip back to the first page because that's where it shows all your information. Let's go through question A together, and then I'll give you some time to actually do these questions here. What we're going to do next is we're going to touch base after around 15 minutes. Okay, so I'll pause the recording. I'll let you do your work, give you time. We'll go around, we'll help you out, and yeah, we'll move on. Okay. What's the first thing that we do when we look at this question here, part A? Annotate. Okay, so you annotate in that top section there. I'll just make this bigger so it's easier for you to see. First part we annotate is. Right, but what's the scenario here? Are we borrowing or are we putting in money?
Putting in.
Yeah. I'm missing something here. I'm missing the entire first sentence at the top here. What's it saying? Okay. What does the compounded value mean? What letter is that? A, the total amount, right? We're trying to find the total amount here. So sometimes you can see that A is like a compounded amount. A can be also said the total value, right? It's glitching a lot, sorry. Over the interest period. Okay, so we know that this is an investment. So if I was to add anything here, we'll just write a little note and write investment there, just so that you know what the scenario is talking about. Oh, goodness. You can ask Miss. I'd like you to go through and give this a try of annotating this question. If you've already annotated it, I'm going to go through and annotate it as well. Thanks. So we want to find which value? The compounded value, which is A. So we don't know what our A is at the moment. Notice here we have all of our ingredients listed down now. How do we start our solution? What do we start off with? The formula. Okay, so everyone, please write out your formula. Yes? Sorry, not 356. Thank you. Where'd you get that information? On the table, correct. On the first page, yeah?
No, he sits from David.
Oh, from David. The table.
Actually, it's the 65 bars.
Yeah. So this is where if you don't know what your C value is, you can turn to the first page to get that information. Understood? What's our next step? Substitute. Okay, we're going to substitute now. So instead of P, we're going to write 870. The 1 here stays the same. The R becomes 3.5. 100 times What's our C? 365. And what's our N? Right, how do we find our N? Like, where's it in our notes? First page, can everyone turn to your first page, please? If you've highlighted, it's in the little rectangle area. Yes? C times Y. Okay, so I might write a little extra note here. N is equal to C times Y. So what's our C? 365 times 2.4. If you go to your calculator, 365 times 2.4 is, okay, 876. So what does this mean? This 876 here means that you compound or you snowball 876 times over the course of 2.4 years. So how many days is there in a year? Okay, how many days are there in 2 years? Times 2, right? But this is 2.4. So you would just multiply 365 by 2.4 years. Okay, that gives you 876. So let's go back to here. What do we replace with the N? 876. So if you type this into your calculator, you should end up with a number. Now, for those of you who don't have a calculator, please, first of all, get your calculator. Or right now, if you don't have one, please share with someone. You need to know how to type this in the calculator. So let's say you're on your calculator. These are the buttons you would press. I'm just going to write it in green here. 870 times, open a bracket, 1 plus, I'm going to get you to the bracket. So on your calculator, this is what you type out, 870. There's a times there. You open the bracket, 1 plus 3.5. This is the same as divide. Divide. This little section here happens inside the bracket. So you have to put a bracket, 100 times 365. Close the bracket. That's that bracket there. This bigger bracket here is the same as this one. And then this is in the power, right? So you have to press, either you have a hat, or you have X with a B on it, or X with a little box on it. You press that button, and then you put 876. Sorry? 3.5, that's a decimal, yes. Can I get a number from someone? So the last step there is your answer. So what I'm going to do now is I'm going to pause the recording for a bit. I'm going to give you some time to work through questions A through to F. Oh, right in the way. If you don't have enough space to do it on the paper, complete this question in your book. Okay. So for those who've already done this, I'm going to go through it now. 2.5 years is your Y or your T. 4.6% per annum is your R. It's the idea of compounded. So the equation that you'll be using is the A equals. And this idea of quarterly means that C is equal to 4. Sorry? Yep, it's recording. So we wanted to find the compounded amounts. What's the compounded amount? What letter? A, okay. So start with a formula. To the power of n. Do we need to do an extra calculation here? Which letter do we need to find in the equation? N. Okay, so we're going to do a bit of a side calculation here. N equals C times Y. How many times are we compounding a year? 4 times. How many years? 2.5. What's 4 times 2.5? 10. What's the next step? Substitute. Fantastic. Okay. Next step, type it into your calculator. Yeah, so that's the speed that you should be doing it at in the test. So it's just to show you how to go. I'm completing this because we have more questions to complete as well, yeah? Second. Your cat. This next week. Next week. Wednesday next week or Friday next week. Yeah, probably. Have a look here before it said 806. How many decimal places do we want? 2. So we round that 6 to that 0. Do we round it up or down? And it rounds up to a 1. So on your question sheet, annotate it there. And then in your book, you can just write it out. Does that make sense? It should be easy once you get the gist of it. Whoops, wrong one. P, 3.5 years. What can we write Y as? Yeah, we can write 3.5 years instead. Am I going too fast? 6 monthly. C is equal to 2. Okay, you can find that information in the table at the top on the first page. Here it says 6 monthly. That means C is equal to 2. Okay. So start with the formula because we were trying to find our A value. I might do a bit of an extension for this question here. So C equals to 2, sorry. Remember, we also need to find our N, so we may as well find our N here. That's 2.3.2 times 3.5, which is 7. Start with a formula. Substitute. Now, if you're finding this process not too bad, like if you understand what's going on, then you need to develop your speed. Understood? So if you know exactly what you're doing, write faster, type faster. (9.2 over 100 times 2 to the power of 7. Give me a sec, it's gonna load. So what is that? What is this number here? $20,002,760.57, right? Wait, that's 202,000. What does this actually mean? What number does this actually mean? Sorry? No, like, what does this whole thing mean? No, it doesn't round up. We'll leave it at 0.57. Because in your bank account, right? You don't see it rounding off the nearest cent. Usually it'll just, sorry, you don't see it rounded off to like 60 cents, yeah? It will stay as 0.57, yeah? What does this number mean? It's a really big number, isn't it? What's our scenario? What are we doing? We're compounding, but what are we doing with our money? How much money would we have to start with?
185.
Okay, 148,000 or 148K, yeah? You have that money in your pocket right now. In this scenario here, we are giving or investing, right? So we're investing, we're putting in the money. We're going to leave that there for how long? 3.5 years. After 3.5 years, we go look at our bank account now. What number shows?
102,000.
Yeah, this bottom number here. So how much, let's call it profit. What's another word for profit or extra money? Interest. How much interest did we make over the 3.5 years? We made a fair bit, right? How do we calculate how much we have from 148K to this amount here? You take away the numbers. So if you want to find how much interest you make, this is another little question here. If you want to find out your interest, you take away your amount and your principal. So you know how you said, okay, I want to actually find out how much it takes. You subtract the two numbers. Smaller number minus the bigger number. Bigger minus smaller. And you can see here that A is 202,760.57 minus 148K. What's this equal to?
54,760 and 57.
54,000
760 and 7 cents.
and 57 cents. If I leave my answer like that, would I get full marks? $sign. Okay, interest here. What does this number mean? Yes, over 3.5 years, you accumulated $54,000 of interest. So if you invest, you get back money. All right, you get back this much money back into your pocket. Does that make sense? It's extra. Think of it as like profit for yourself, yeah? So are you gaining or are you losing? Gaining, correct. All right. Let's this is interesting here. Investor at some percent. I want you to have a look at this question here. It's a bit of an extension one, right? Now, remember when we use this formula here, George. When we use this formula here, this is the shortcut way, right? We're skipping all those steps and we're jumping straight to the end result, right? Remember how we calculated it step by step? That's what we're going to try to do for this question here. Right? Let's see, after we read this, let's see what information we can grab from here. So the scenario is, or the story, is that after selling their house and paying off their mortgage, Mr. and Mrs. Fong have $73,600. They plan to invest it at 7% per annum. So what are they doing with their money? They're investing it. Okay, so that's probably worthwhile underlining. So that's our scenario. Just invest. We don't need to write anything for it. We just need to be aware that we're investing, right? Is there any other figure so far that we should underline? Yeah, the money. $73,600. That's how much money you start with. That's your principal. Okay. At 7% per annum, which is the rate. So that's our little r. And it's compounded. So compounded annually. What does annually mean? C equals 1, once a year. Okay, excellent. What's the question asking now? After such and such, right? What is the value of their investment? What letter does that stand for? A? Or you can also say V, right? Now, it's a bit complicated because we actually have a lot of variables flying around. So how about we do this step by step, 1 year after the next, after the next. Does that make sense? 1 year after the next, after the next. Does that make sense? So how do we do this step by step again? Since it's only compounding once a year, how much would your amount be after 1 year? How would you calculate that? Okay. You have 73,600. Okay, we're trying to think about it too complicated, right? Let's go back to the basic principles. You're investing. So after 1 year, do you make more money or do you make less money? Okay, so how much more money are we making? 7% of how much? Okay, so we're finding 7% of this amount. And then what's your total amount then? Because now you have your interest. We know how to calculate our interest. We got to add that on to. You got to add that on to how much you already have, right? So let's say, I'll draw this up like a little bar, right? You already have $73,600. All right. At the end of the first year, though, you gain 7% interest, right? So This is green money. This is like add-ons, right? You add on 7% of. Does this make more sense visually? If I draw it out like that? So if we want to find our amount at the end of 1 year, we'll go $73,600 plus. How do we write this as a mathematical kind of formula? 7 over 100 times. Okay, let me recap this for you. Yesterday, in our lesson, what did we do here? That gives us this amount, right? And we added it together. Isn't that the same process? Do you remember this? So is this coming together now? Does it make sense? So this is how you find out, because this is the extra bit of money. That's your interest there. And this is how much you start with. You have to add it together to find your total amount. Make sense? So we're doing the same thing here. So how much is it worth after 1 year? Can you please type this into your calculator? What? How much? 5,000. Which part? This part. Okay, so that part there is worth 5,152 on the dot and 0 cents. Okay. So notice here, we're going to end up with $73,600 plus $5,152 of interest, right? That's how much extra money you get on the first year. So how much would your bank account show? 8,000. Sorry?
$78,752.0.
Does that make sense? How much would you have after 2 years now? So this is how much you have now. It's grown, yeah? At the end of the second year, what happens? Do you make more money or less money? More, right? How much more? 7% more of how much now?
7.75.
Correct. Now, there has to be a better way of doing this, right? Because we can't always do this. Yes? Yes. We're going to use the formula, but we're going to do it just step by step, right? So who's done this before? You have one, and you do this, you've probably done this on your scientific calculator. You go +1, and then you spam it. And then you race your friend to see who gets the higher number faster. Yes? You've done that before? This is the same thing, except we're going to use a different formula. So we're starting off with 73,600. That's like our 1, right? And you know how we go +1, +1, +1? We're going to do something to this number here. Do we want our number to grow, or do we want it to become smaller? We want it to grow, right? By how much? We want it to grow by 7%. So what was that? 1 plus 7 over 100 times. How many times do we compound per year? Once, right? Twice. Now, we only want to see how often it grows after how many years? 1 year. So 1 year after the next, after the next. So we're going to go to the power of 1. Does this make sense so far? We press enter. But now we want to use not this number anymore. We don't want to use the 7,000. We want to use our answer from before. So I'm gonna go control answer. And we want to multiply it by this number. That's similar to our +1 here. See how we go +1? But instead of going +1, we're gonna times this number here. And then we spam enter. Can you see how it's growing? Keeps growing. And it keeps growing, right? So how many times did we repeat? Here was our start. This is 1 after 1 year. Yes? What's this after 3 years, 4 years, 5 years, 6 years? So how many years does it take for it to grow past $110,000? 6 years. Does this make sense? Now, the good thing about this is that it's recorded, so you can actually see how I explain this, right? Go back and rewatch this video, so you can explore what happens. So these are our problems. Now, don't think of this as like a problem that you'll just find in a textbook. These things do happen in real life, right? Now, have I explained to you why this is important to learn? Say you go to the bank, like just before you pack up, because otherwise there's going to be a lot of rustling, right? Yes. Say you go to the bank. You tell the person who's sitting behind the desk, okay, I want to invest and I want to make this much money, right? Who's putting in the numbers into the system? Is it a robot or a person? So what's going to happen? Yes, potentially, right? Potentially they might make a mistake. What happens if they accidentally put in 6 instead of 7? Are you going to make more money or less money? Way less, right? So just the difference of one number can cause a huge effect. It snowballs, right? So this is why you need to learn this. If you go to the bank and you borrow money and they say, okay, you're going to make this much amount of money over this many years using these values here, right? You say, okay, give me a second. I'm going to do a bit of calculations. Not because you don't tell them, but personally me, I don't trust them fully. Because they're still susceptible to making mistakes, right? This has happened to a friend of mine. I went with them to a car dealer. They agreed that they would pay back on the loan this amount of money, but they actually made my friend pay back more because they actually calculated incorrectly. I sat there, I said, okay, tell me how you got these numbers using these conditions. We calculated it together, me and the car dealer calculated it again. And then this is what the car dealer said. Oh, sorry, I accidentally put in one of the numbers incorrectly. So I helped my friend from save thousands of dollars because the car dealer made a mistake. Yes? Sorry? Yeah, well, not that he didn't get his money back. He just paid the correct amount instead of paying more. So that's during your initial consultation, yeah? You make the plan and then you pay it. But can you imagine if I wasn't there and they went forward with it? My friend would have had to pay that extra amount. Same thing with houses, yeah? Now, a car is worth $30,000, right? Imagine if you were doing this for a house loan. Yeah, or let's say a house now in closer to the city is at least $1 million, right? Can you imagine if they made one mistake here? You'd be paying back thousands of dollars, tens of thousands of dollars. Does this make sense as to why this is important? So learn it well. Okay, you can pack up.